Hello and welcome to the Omnex webinar, The Disruption in the Automotive Market, EV/AV Vehicles, and What It Means for You. During this webinar, if you have any questions, please enter them in the questions dialog box, and the presenter will get to them at the end of the presentation. Today's presenter is Chad Keimel, Omnex CTO. We're still waiting for some key customers to join, so we'll be starting in about 3 minutes. During this time, there will be no sound. Hello and welcome to the Omnex webinar, The Disruption in the Automotive Market, EV/AV Vehicles, What It Means for You. Today's presentation is being conducted by Chad Keimel, Omnex CTO. Chad Keimel is the CTO and founder of Omnex, an international consulting and training organization headquartered in Ann Arbor, Michigan. Over the course of Chad's successful career, he has served on the Malcolm Baldrige Board of Examiners and received numerous quality achievement awards, including the Quality Professional of the Year Award from the American Society for Quality. Chad has developed and teaches auditor training for ISO 9001, 14001, 45001, integrated management systems for lead auditor, and many others. Chad is the founder of AQSR, a global registrar that routinely provided integrated audits for QMS, EMS, and OHSMS. Chad is on the committees that write for ISO 9001, 14001, and 45001. Chad has been working in the automotive industry for over 30 plus years. Chad is currently working on writing books for ISO 14001, IATF 16949, and he has written many other books, including one on integrated management systems. During this webinar, if you have any questions, please enter them in your questions dialog box, and Chad will get to them at the end of the webinar. This webinar is being recorded and will be provided to all attendees after the webinar. You will be contacted by someone from Omnex with how to access the webinar. Go ahead, Chad. You can start the webinar.
Miles, thank you very much. Good afternoon, everyone. Let's spend the next hour talking about the disruption in the automotive market and really, what does that mean to each one of us? And here at Omnex, this is something we saw coming 3 years ago, and we prepared for this change. So, number one, I want to make sure you're aware of the change, aware of what it means, and then maybe you can assess what it means to you personally. Folks, a little bit about Omnex. I imagine many of you have attended the webinars here before. Just to tell you, we're headquartered here in Ann Arbor, Michigan, where we've been here for 33 some years. And some of the things we have done that sort of shaped Omnex into who we are is the work we did actually in 1993 writing QoS for Ford Motor Company and then doing a global rollout for the what we call the emerging market, working with Ford Motor Company. And it has a life of its own. It's moving. So we do a lot of work in management systems. We have done tons of work in Lean Six Sigma, as you might imagine, in the automotive industry. And of course, what we have done now is come up with our training series for electric and autonomous vehicles, and also, our competencies for our own consultants, for this market. This is a little bit on the Omnex global offices, and as I mentioned to you, there were sort of a couple of events that made us as global as we are. The Ford emerging market work that we did. We helped the semiconductor industry in Southeast Asia, working with an industry group called SAC. And of course, today we're doing global work for we are the global training providers for Magna and Lear. All that makes us even that much more global. All right. When we finish this webinar, here is the questions I'd like you to answer. What does this change mean for new product development? I think I hit that pretty hard. Maybe less so in IATF 16949, so we should talk about that if it's important to you. And then we'll talk about the standards emerging from this market shift. I'd like you to know that. Third, what are the competencies key to your engineering department and then key to your role? Hang on one second. Miles, let's administer the poll. Folks, in this poll, if you are a part of Omnex and you're in the audience, you can just ignore it. I want to see what the customers are who are here, and whether they have heard this webinar before. Miles, I'll just mention to you, I seem to be in some sort of a timer in these slides, and slides seem to be moving on their own. I may need some help as we go through. All right, here's the agenda, folks. And the agenda will spend maybe 20 minutes to 25 minutes on, in terms of what I learned from the poll. I'll try to see if I should spend more time or less time talking about the automotive market, why electric and autonomous cars are different. Anyhow, starting with a third bullet, I'll try to spend more time. Then we'll talk about competencies for engineering and new product development, and roles and definitions of competencies for the organization. So I'm going to quickly look at the results of the poll. All right. So the majority of you have not seen this webinar before. So folks, I am not going to cut short the first few slides. And I don't mean this webinar itself, but I've done a number of webinars on electric and autonomous vehicles. For those of you who have seen, webinars I've done, some of the first slides may be same or similar. All right. So just to understand what's happening in our market, it is really countries announcing plans for phasing out diesel and gas vehicles. In the US, it's really California, and as you may or may not know, the US government is taken California to court, trying to not make them be as environmental in terms of emissions as the California. Folks, hang on for a second. I'm just going to get a little help here in terms of timers. I'm just going to go off. I'm going to, you will not see anything right now. And we're just going to fix this whole issue of why my slides are moving forward. Maybe on a template that has a timer on it or some sort of setting in the computer, we will. I'm going to pause here for a second. You won't hear anything for maybe 30 seconds. Folks, let's continue here. I was mentioning to you that it's really countries that are moving the markets. And of course, based on what the countries are announcing in terms of bans, you'll see that the whole automotive market has announced that the next set of vehicles are coming out with all electric. And soon to follow after the electric, it is autonomous cars. So you can see here everyone from Volkswagen to GM to BMW to, let's pick somebody like Maruti Suzuki in India. You know, some of the big markets in the world are really today, the Chinese market is bigger than the US market. So you have, you know, the big players, and of course, GM and Volkswagen still are some of the key players, and they have fully announced a move into electric vehicle and then from EV into AV. Folks, one more thing very key to your organization for you to know is that the automotive market is, so we didn't fix the problem, you can tell, but it wants to go on its own. It is right around about 35%, you know, hardware and software, and that's going to become 50%. And of course, the software is now it's just not hardware. It is, well, you can say mechatronic is the word that they use for the mechanical and hardware designs that we have. And if you just to go back in history, when the standard first came out in 2011, it was, you know, it was really because of the Toyota incident, which for the braking incident that they called a mechatronic issue. And 26262, or functional safety, was really, you know, expedited as a standard because of that. So what do our OEMs tell us today? They tell us that the big warranty issues that they're having is all software. You know, I kept this slide in here only to talk about this 1.5 trillion, you know, revenue pool. When you do go, you know, people worry that if you go autonomous vehicles, that, you know, this, you know, people will buy less cars. But I'll tell you this, because cars will be, or autonomous vehicles will be moved and will be used in so many different ways, the market will actually grow by 30%. So what are we saying? Number one, that the electric vehicles and autonomous vehicles are taking over. There'll be a slow shift from combustion engines to electric vehicles and autonomous vehicles. Number two, what we're saying is the car itself, even the combustion car, is getting to be more and more electronic and software. Number three, we said software is a big warranty issue. If I didn't make that point, software is a key issue, and that's why you're starting to see OEMs like Ford put together, groups to work on ASPICE. The last thing I mentioned then is that shift in sales to $1.5 trillion and 30% growth in the pool. All right, so these are the questions we have to ask. If there's this change here, I haven't yet talked about what the product means, so maybe I'm a little early asking this question, but this is the question we'll ask when we're done with the EV/AV section. This change in the product mix, what does that mean to new product development? What does it mean to the management system we have today? Okay, we'll try to now answer it by what Omnex calls its 7 levers. And let me also say this. We are just launching next week. We'll be launching an EV/AV site. In fact, you can go visit it right now. It's evav.omnex.com. Maybe write that down someplace. And you will see all the information you need, including many of the webinars that I've given on EV and AV. Next, what we need to know, I would imagine many of you attending today are either involved in quality, involved in functional safety, cybersecurity, or engineering, and you're wondering, what are the competencies that are key to me and to my organization? And last, how do I acquire these? Okay, so I think you need to know there's a global race afoot because there's gold in them dar hills. It even makes more sense. I attend some of these webinars in San Francisco, and it's but I can just tell you this is seen as a gold rush, the new gold rush, and companies are vying to get there first. And let me just tell you, there are some companies that seem to be very, very well set, and there are others that are a long way off. And the gold, folks, is not in the electric vehicles. The gold is really in autonomous. The company that gets there first in autonomous vehicles and stays there even for a year is going to grab the market share. And if you look at the bet the stock market is making, they're saying Tesla has got a better, might get there faster than either GM or Ford, because the market worth of Tesla is equals or greater than GM and Ford put together. So that's what the market has to say. All right, this is some data, by the way, for the global automotive market. And I have to tell you, there are many, many, many more that are not part of this IATF certification. The new players in the market just don't seem to understand what standards they need to implement so that, number one, the cars have quality, the cars are functionally safe, cybersecurity, and of course, SOTF is a very key item in this mix. So here is the IATF, and you can see, I don't have the total number, but I'll just point out to you, North America only has 6,226. India almost has the same of 5,305. Look at Korea. Okay, 5,189. And then you can see Asia in China, almost 5 times the number of IATF certifications. But folks, the current players are not going to be the future players. Let me just say that clearly. So here's the EV/AV market, and you can see the cumulative sales by automaker, and you can see GM made the right move when they introduced their electric vehicle a few years ago, and 211 vehicles to Tesla's 381. And of course, many new automakers, and several of these automakers, by the way, at least 2 of them, are very much closely associated with Ford Motor Company. Okay, so this is some of the new players in the market, and you can see here there are many in services, safety and security, intelligence, and I have to tell you, AI is going to be a big player in autonomous cars. Then you see autonomy, infrastructure, intelligent manufacturing, ongoing onboard sensors. Wow. Let's see if we can try to explain all these different companies to you. Then here we have the traditional players, all vying, trying to move into this autonomous market. Every one of them has announced some sort of a program or some sort of an alliance, all right, in terms of moving into the autonomous space. So, folks, we also have Europe, who is vying for this market. When I look at the activity, I would put China at number 1. Look at the new NEEAV, means stands for new electric vehicle and autonomous vehicle companies. And these are come from the licenses. I think I have the 300 licenses for electric, autonomous, or electric batteries in China. Okay. And let me just make a comment. I have been, I don't quite understand it. Companies are coming to us after the product is developed, asking us how to put functional safety into the design or cybersecurity into the design. The companies will be nameless, but that's what's happening. People are looking at putting these safety systems and cybersecurity systems in after design, and folks, fundamentally, that's not okay. All right. So I had a company that's right now got product running in China, I forget the city's name. They have 30 vehicles running, whereas they're just now, when they said that, they were just asking how to put functional safety into their design. All right. Let's understand as we go forward to understand the impact on design that these are the components of electric vehicle. And you can see fundamentally the electric vehicle has fewer components than than a internal combustion engine, and fairly simple. But of course, it has an incredible amount of new technology, increased hardware and software, and part of that is that they did not need to be connected. But of course, today's vehicles are infinitely connected with the outside world. I'll talk about that in a second. Many safety concerns in EV. Why, you might say? Well, really, it's the battery pack. Each of those battery packs have enough, power in them to take out a city block. cybersecurity concerns, supply chain concerns. And of course, here is all the different issues. It's not the full list of the battery pack and the electric vehicle. Oh, I thought I had cybersecurity here, but the cybersecurity, is a number of different issues with cybersecurity. I talk more about that when I get to the autonomous vehicle section, which is now. So let's understand the AV basics and understand the big part of AV, autonomous vehicles, is the self-driving vehicle and is a perception system. Whether you go level 3, level 4, or level 5 SAE, it's the perception system. And folks, in this webinar, I'm not going to spend a lot of time on SAE level 1 through level 5. I have spoken quite a bit about that in previous webinars. Please go and listen to one of the similar sounding names, but it'll be a different webinar. But really, for autonomous car, this is key. A couple of things you notice from here is the amount of hardware, and along with that, of course, is a software. Soon as you say perception systems, you have software to deal with. And let me just tell you, to identify the perception is so key. You have AI to go with it. I put this slide together so that you just understand the amount of hardware between SAE level 1 through level 5, and to say a level 5 vehicle, they think will have 28 to 32 sensors, whereas a level 4 will have 25 to 28 sensors. So a tremendous amount of hardware. And folks, with this hardware, you can almost imagine there's a tremendous amount of software. So here is the AV platform, and here are some of the safety critical components. You can see perception is a key area, redundant collision detection, and of course, immediately you have to be concerned about vehicle-to-vehicle communication. Signal communications inside the vehicle, and to have an alternative path if the primary fails. And the idea is, if something happens, the AI system has to kick in, and you don't want to go to the driver unless it's a last resort. And then the self-driving computer, vehicle localization, electric power, steering and braking, system robustness, the health monitoring are all safety critical components. All right, what about automotive threats and technologies? Here are all the main technologies, and every one of them is a cybersecurity threat from the ECU, the control units. I forget now exactly how many we have, somewhere between 30 and 45 ECU. I hope it's not 100 and I'm off on it. But I was just in a cybersecurity certification class, and I forget the number that was mentioned by our SME. Then, of course, inside the vehicle, we have CAN, we have Ethernet and Internet, we have sensors, wireless communication, infotainment system, telematic subsystems, and actuators. All of them, folks, are areas hackers can hack into. So vehicle driving functions can be controlled. So just to tell you that anytime you have drive-by-wire or any kind of computer control or the CAN bus, all areas which are threats that we have to, through threat and risk analysis, ATARA, we have to factor out and ensure our design. Here's an example of a radar subsystem where somebody could mimic signals and take over and mimic radar signals. And if they mimic radar signals, folks, we are in trouble, okay? Because they could either make us have an accident or they could make us have, drive us somewhere else. Okay. Maybe not by radar, but it has consequences. All right. What does this mean to the automotive industry and the standards in the automotive industry? So what we have to say is that you can see these 7 different bullets, which I'll talk to in a second, all impacting IATF 16949. There's new product development that I'll be talking about, and the changes in the new product development, all of them impact your IATF 16949. So folks, those of you in the new EV AV market or in that division need to fundamentally redo your business management system, which is governed by IATF 16949. Of course, you still need to meet IATF 16949, but fundamentally, the system has to have some additional requirements. Then we have functional safety, as you saw, one of the fundamental areas in EV and autonomous vehicles, electric vehicles and autonomous vehicles, is automotive safety. Let me jump here to cybersecurity 6. Cybersecurity is a key area of concern, and Omnex is forecasting this is the year where we're going to see cyber attacks where people take over cars. I don't know if you saw the video of a device where people break into your car, in the mall or elsewhere, as you lock your car and walk away, how they're able to get your security signal and just play it and get into your car. Okay, well, that's being used pretty soon to the start of your car, because we audited that system and we worked with that company. They're using also your thumbprint or your fingerprint, so it's going to be more robust. But cybersecurity, the year of cybersecurity is this year because there are weaknesses in the designs that we see. Let me just go to SOTIF. SOTIF is the standard for the perception systems to ensure that the vehicle is able to judge what's happening in the road and make the right decision. So the scenarios that have to be played out and the system has to follow, it is SOTIF. All right, I'll jump now. Automotive Spice is a system developed just for software. Though it has our systems, software, and support processes, Automotive Spice's main function was for the quality of the software. All right, folks, in these new standards, it is really important that the requirements flow down to the supply chain. Folks, just hang on. I'm getting a little help here. Let's try this. I'm told this might fix the movement problem. Somewhere we have a timer on, and we're not quite sure where it is. It's some sort of a universal setting. All right. So where was I? I was still in this slide here, and I was telling you some of the practices that we have, which I'll share with you in the next slide. Requirements, testing, the distributed interface agreement from both cybersecurity and functional safety, and the joint agreement from SPICE all mean that the supplier and the customer need to work in lockstep, and then the supplier and the sub-supplier needs to work in lockstep. All of these have a big impact on the supply chain practices. And then let me just say this, I never get to talk about Agile APQP. All of you that are doing hardware design and software design today need to look at Agile at scale. And of course, for us in automotive, it is Agile APQP. This is the only slide I spend on, in terms of the new standards, but the new standards bring in big impacts on the existing systems. Folks, imagine that this is the slide of the impact on IATF 16949. So we have the V model. So what does a V model mean? I'll get to talk to you about that again one second when I talk about the impact of this, the systems engineering. Requirements flow down, all the way down, and then traceability up and down. And I just wanted to say, requirements go down, testing comes up, okay? The levels of testing, you need to show how you're doing the, unit testing in software, integration testing, then same thing with hardware, then hardware and software testing, and then hardware and software and the system integration testing, and then qualification testing of the system. All right, what does this all mean? All this means that there's a big impact for competencies in engineering, okay? And let's start first with this change and understand that today we're talking about a safety cycle, engineering cycle and a cybersecurity cycle, and we have to put in a concept phase in our new product development. So of course, you can still follow APQP, the new product development process the automotive industry follows, but you also have what is called a concept phase where fundamental things get defined, and it's key for the concept phase as the initiation of design. This is where we'll define what is called the cybersecurity, integrity levels, SILs, and this is also where we were coming up with the automotive safety integrity levels, okay, ASILs. Then what we see is in product development, we see the design is broken down into system, hardware, and software. So because we're doing a lot of work here in this area for the last couple of years, and much more in the last 2 years, I can tell you our OEMs and our tier ones are scrambling because this is not the way they're organized today. And of course, these standards have an impact on manufacturing as well. So let's talk a little bit about this V model. This is the V model of systems engineering. And folks, what we see here is that if this subsystems has hardware and software, and the subsystems has, other systems of its own, hardware and software, you can see there's an entire supply chain that we need to flow out to, back to, and then flow back into. So this new product development process will have to adopt this structure, and it will have to fundamentally change, okay? So we're talking about fundamental change into the new product development process. So look at this. There is something called a V at the from the system all the way to the hardware and software. And folks, I like to tell people that the automotive industry is not like this. Even very simple companies we work with have 30 to 60, simple BOMs have 50 to 60 suppliers, which means there's a tremendous amount of information that needs to flow down just to the tier 2 of a tier 1. And just to tell you this V, there are 3 small V's in the subsystem, the hardware and the software. I'm only saying that this is fundamentally different from the way APQP works. And what I know, all of this is done in phase 2 of APQP. So a major rewrite of new product development process is needed, where we put in systems engineering. So these are the competencies, there's a short list of competencies that you need to have, in your current engineering department. This idea of systems engineering needs to be there. In fact, we have fundamentally don't even have system engineers. And if we do, they're not trained. We need to have hardware and mechatronic systems development. We need to have embedded software and AI capabilities. Folks, at Omnex, we've been helping companies. We ourselves recently brought in a design group that does hardware and software because we do understand we're going to have to help our customers put these competencies in place. All right. So hardware and software and AI, because these perception systems need AI. Plus, in automotive design, we need to start putting in AI capabilities. Functional safety and SOTF, cybersecurity competencies, the connectivity car to car, and there's a different language in terms of connecting between the infrastructure and the car, okay? And then, of course, configuration management. And it's not as simple as it seems. These are fundamental new competencies that we in the automotive industries don't have. What do we have next? Well, this is what we need to do. We need to redesign new product development to include these competencies. Systems engineering, requirements management. In requirements management, I don't know if you knew, you need to have a unique ID for every requirement, and that requirement needs to be traceable to the I'll go by the specs, but I'm going to stay away from the specs and just tell you generally it needs to go into hardware, it needs to go into software, it needs to go into the subsystem, it needs to go into the component. And it's not just requirements. Requirements have verification criteria, and then it has test cases, and then it has test results. So the traceability has to happen right down to the test data. As you can see, linkages and traceability. You need to have functional safety and SOTF and the linkages between that, because though you may think functional safety is a silo and cybersecurity is a silo, they still are part of the design process. And then, of course, automotive spice for the embedded software. I like to tell my customers, and I've seen software grow. We at Omnex here have been around for 33 years, and we've been implementing, auditing, and putting systems in place for 33 years. So right around 20 years ago, we started seeing small software groups, and they started growing in size. Now, of course, for Omnex, we have worked with just about everybody in Silicon Valley, and we're still working with many of the companies in Silicon Valley going into EV, AV. These small software groups have become large software groups, and of course, in the tier ones and the OEMs, most of you are outsourced software. Is that a good practice or a bad practice? I can just tell you there's a huge amount of problem in embedded software. This is something we need to solve. All right. So what then are some of the roles in system engineering? Folks, I am going to pause here for a second and allow you to write down some questions. I'm going to take it out presentation mode so the screen does not change. And let me see what kind of questions allow you to ask me some questions before we go on. We're going to have at least 10 minutes, I think, of Q&A. And let me let you do that. Give you about 2 minutes to write down any questions you have so far in terms of what you see, what you have seen so far in the presentation. All right, let's continue. Here are the roles in systems engineering. You know, in your organization, is systems engineering new? Do you have a systems engineering department that, they are the folks who have to put the whole system together, design the system, and all the requirements need to start there. In fact, we did an assessment last year on a project for EVAV, and we saw that they had requirements, but the requirements were not linked to the customers' requirements. And then we didn't see any requirements beyond the top level requirements, and it just jumped down after that into hardware design and software unit code. So our software requirements and then unit code. Fundamentally not acceptable. You can think of it as a major nonconformance. All right, hang on one second. And you can see here, so I did not want to be in presentation mode because the slide kept moving. Hang on one second. I'm having a discussion here with our department. All right, small workaround. So so at most places, when we usually first visit, there is no systems engineer, and then they quickly make a system engineer that they find, but there's absolutely no training that the systems engineer has. Okay, so here are some of the, and this is not an exhaustive list. The systems engineer needs to understand what is a V model. They need to know how to write requirements. The requirements are a major area of nonconformances we typically give, not just for system, but for hardware and software. They need to know DFMEA and testing DVPNR, especially the systems engineer. Well, for DVPNR that is, but the system, the hardware, and the software need to have that. Now, in this presentation, I don't talk about this, but if you want to know how to easily do the flow down of the V model in automotive design, it is by doing a DFMEA and a DVPNR. More so, maybe in some other webinar, it's a pet subject of mine that requirements need to be tracked as functions and requirements. If you do it as functions and requirements, you can easily fit it into the DFMEA and DVPNR. And of course, depending on which model of DFMEA you use, there's flow down that occurs, in terms of linkages between the system DFMEA and the subsystem DFMEA and the hardware DFMEA and the software DFMEA. What else does a systems engineer need to know? The systems engineer really needs to have what we call a level 2 competency. So those of you who get certified by Omnex in a 5-day class only have what we call a level 1 competency in functional safety, cybersecurity, SOTIF, and ASPICE. You need to have certifications to show that you at least have the initial competency, but then you need to show that. So we have a second level class where we teach case studies to make sure you know actually how to practice the tools, which is we call level 2. We do that inside the organization, That is the level of competency a systems engineer needs to have. Then we have the block diagram, allocation matrices. That's how you allocate from the system into the hardware, or from the system to the subsystem. And of course, you have to identify how to create interface functions, or what they call the architectural requirements. And there are a few more, other than the block diagram. I forget the name of the diagrams. There are a few more diagrams that you have to do. And in those architectural requirements is where you do the integration testing. Fundamental understanding of these concepts need to be there. And then, of course, the systems engineer needs to understand the safety case and or the cybersecurity case. Since they are the folks who are responsible for the entire system, the safety case and the cybersecurity case can start there. Then, of course, you have to ask the question, should that be an engineering responsibility, or should that be a responsibility of quality? So, hang on one second here. What then are some of the organizations fundamentally impacted by these new standards? And folks, it's not just engineering. Engineering we just talked about. Purchasing has to understand it, because the requirements for suppliers, competency of suppliers, costing from suppliers has changed. So purchasing needs to understand it. Sales needs to understand it, so they ask for the right information from your customer. Your SQEs need to be fundamentally retrained, and we have to rewrite the SQE process, because suddenly fundamental changes of DIA, cybersecurity interface requirements, and distributed interface agreements for cybersecurity, functional safety, SOTIF, ASPICE, all need to play in place, and the SQE with purchasing have to take the lead role there. And then the SQE will need to keep track of this, the project plan, also called a functional safety plan or a cybersecurity plan, when you're working with suppliers. And then what we have, HR, competencies are fundamentally changing, job descriptions are fundamentally changing. And then of course, the role of quality is changing. Just look at the NPD change. So this is something you may or may not have known about, that the new standards require quality assurance. It requires the quality to go in and check the quality of the work product. In fact, there needs to be a verification of a peer review before that, and then a review of work products. It's there in ASPICE, it's there in functional safety, it's there in cybersecurity. Next, the standard requires processes to be assessed, and ensuring that they meet the objectives. So there are a couple of different types of audits and assessments that need to be done. There needs to be audits, which is all the projects. There needs to be assessment, which is a project level, and something called confirmation review, which is that work product review I was talking to you about. These suddenly are enhanced requirements of quality in new product development. There are gate reviews for each of these, APQP, ASPICE, cybersecurity, functional safety. Then, of course, very stringent requirements for corrective action, change management, and configuration management. In these new standards, when you do problem solving or corrective action, they require you to do change management. Because, if you change a requirement, if there's a quality issue and you change a requirement in the system, hardware, or software, that requirement will impact many other requirements, and it might even make you go back to an earlier phase and redo many actions. So change management and corrective action suddenly are inherently linked together. And big changes you can see, because one of the topics I had is the changes in IATF 16949, and then we never ever had configuration management requirements in IATF 16949. Then the last bullet here, preparing the quality assurance KPI and conducting management reviews at a project level around the QA functions is another requirement coming from these standards. How about the SQE? The role of the SQE suddenly, includes preparation of this distributed interface agreement, making sure all the requirements of APQP, ASPICE, functional safety, and cybersecurity are included, conducting the PPAP review, the safety case, and the cybersecurity reviews at the suppliers, conducting audits, assessments, and work products reviews, depending on the CIL, CIL level, cybersecurity level, the supplier, or the ASIL level. And then, of course, problem resolution, corrective action, and monitoring supplier metrics. So, folks, we're winding down then to the end of this presentation, and I just want to check if we are able to answer these 4 questions. What does this disruption mean to my new product development, and my engineering department? I hope it is very clear. I'll talk about that actually in my summary slide. I hope I've tried to hit upon IATF 16949 also, the impact on 16949. And folks, if you are just implementing IATF 16949 today, and your strategy and goal is EV/AV, you fundamentally need to implement it differently than just the standard today. What are the other standards emerging? And let me just go to the next slide. This is what we'd like to, there are more standards that are coming, but folks, let's get on top of it right now so you don't get further and further behind. These standards need to be integrated into your new product development process. Levers that Omnex talks about. And again, remind you about our website, the evav.omnex.com. And then we try to share with you what competencies are important, giving you an example of a systems engineer, giving you an example of a quality assurance, the quality engineer for new products, a SQE engineer, and how do you acquire these crucial competencies? I really did not share a slide just on that topic, but our idea would be you need to get certified. And the certification exams all have exams, and that will just make you level 1 certified. You become level 2 certified by either implementing things, but if you're the only implementer, we recommend getting level 2 certified inside your company upfront by working through several case studies, and we have level 2 courses and level 2 exams, okay? So that's how you acquire these crucial competencies, getting the certifications and then practicing them, or getting the certifications and getting the level 2 competencies by, working on case studies. So with that, let's summarize what we talked about. And just to tell you, the shift from combustion engine to autonomous vehicles is inevitable. It's going to happen, folks, and it's happening. And with that, it brings in new engineering competencies from systems engineering, hardware and mechatronic systems development capabilities, embedded software and AI capabilities. Along with that, you have to do automotive SPICE and something called AutoZAR, that you have to design based on. Many OEMs are requiring that today as a platform. Much less coding if you use that. Functional safety and SOTF, cybersecurity, automotive car connectivity, configuration management. And folks, these new competencies will require new roles in your engineering department. First, you have to redesign your process. Next, new roles, new competencies. So not only engineering changes, but also all the other key functions also change. And just to leave you with this, how are we meeting this? We came up with 34 different courses to help our customers, 29, 30, 34, yep, 36 actually, courses. And services, how we can help our customers. Added in design, thinking we may have to help you with your designs. Audits, this safety and security certifications is not the training certifications that we do, but it's actually the audit certifications we do for your product and your system. And then, of course, we're working on software tools, which we think are key to the success. And as we speak, we're coming up with software that can do IATF 16949, APQP, functional safety, cybersecurity, ASPICE, and SOTF. So this is the Omnex services. Upcoming webinars from us. We have many more webinars. Please join us. You can see here a very detailed webinar on the engineering V model and implementing it with AIGVDA. One of our SMEs will do that. And all right, I'll just tell you some books I wrote. You know, IATF courses, SPICE, SOTF, Agile, AIGVDA, FMEA, and I see a repeat there, so let me just go by here. And then you actually see also SOTF in that one, functional safety, more functional safety, because we put a lot of work into functional safety, and cybersecurity, which are two key competencies companies need to have. With that, let me take a few questions and then we'll finish up. Folks, I'm being asked, what is SOTF? It means safety of the intended function, or SOTF. It means the product was designed correctly, but still has issues in it. A favorite example, and it's also got people. It hasn't considered customers misusing the product. Both of those come into SOTF. SOTF is very key now in autonomous cars, but I'll explain to you the basics of SOTF by giving you a tier 1 example. Let's say you have a sensor that senses for your airbag in your seat whether all the airbags should come on if you're an adult, or if you're a child, only 4 of them come on, something like that. Okay, and because if it all comes on, the child could get hurt pretty badly. And so what could be then some SOTF issues is that if the designer didn't think through, what if 2 children sat in the front seat, as sometimes happens, or if the child held a heavy box in the front seat between their legs? Would the sensor sense that correctly, or would the sensor think it's adult and make all the airbags come on? So that is an example of SOTF. A misuse example is a driver sitting in the seat and not using the seat belt and buckling it and sitting on top of it. as I've seen people do. So the idea of SOTIF is to make sure you think through what's called scenarios. In terms of autonomous cars, the examples they show is that the perception system is trained to see a human being crossing the street. What if it's somebody dressed in a chicken outfit? There's an example that's put with a by one of our Carnegie Mellon professors who talks about this quite a bit. And will the SOTIF system be able to catch that? Okay, question on the safety case. It shouldn't say safety case, the cybersecurity case or cybersecurity. Let me just say this today. So yes, it's required. Today, if you look into the 26262 2018, you will see that SOTIF needs to be considered as part of when you do functional safety. In the safety case, you got to think about both. Similarly, folks, there's a cybersecurity case that needs to be done for cybersecurity. Very similar requirements, okay, that need to happen. All right. So last question I'll take is about, is Tesla a level 4 or level 5? I can tell you right now, Tesla, I drive a Tesla, and Tesla, I should go back and look at the picture of what is a level 2, a level 3. It's either a level 2 or a level 3. In a level 4 car, it'll be able to, it's called ODD. What does ODD stand for? It's a narrower scope than all of driving, like the highway. If you designed a car that can drive autonomously on the highway, as you know, you can't quite do that yet with the Tesla or with the GM Super Cruise, as they call it, both of them getting accolades from the market. So both of them are either level 2 and level 3, and the gold rush for autonomous cars goes on. And it's a very exciting time for all of us to be in this industry. Major change happening. And who's going to win? Folks, both from your organizational perspective and a personal perspective, is those of you who are prepared and plan and decide to take your careers in your own hands. And your organizations need to fundamentally ask the question, what product am I doing? And is this product going to be there in the EV and the AV? And then, of course, look back inside and bring in the competencies you need. Let me tell you, with the customers, some of the customers that are currently doing mechatronic systems, electronic systems, they are growing phenomenally. They have a tremendous amount of projects. And you should be in that same boat. Folks, with that, I hope you enjoyed this webinar. Thank you for sharing your hour with me. Hope you come and join this, other webinars from Omnex. Folks, thank you very much. Bye-bye, everyone.